This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2017 AP Calculus exam, free response question AB3 BC3. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm the former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question and then the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary of the student performance on this question. Then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors, and where appropriate, I'll present some specific scoring examples. In this problem, we're given that the function f is differentiable on a closed interval, and we also know that f of minus 2 is equal to 7. The graph of f prime is given in this figure, and it consists of 3 line segments and a semicircle. In part A, we need to find the values f of minus 6 and f of 5. In part B, we need to determine the intervals on which f is increasing. In part C, we need to find the absolute minimum value of f on the closed interval minus 6 to 5. And in D, we need to find the values f double prime of minus 5 and f double prime of 3, or explain why they don't exist. Here's how this problem was scored at the reading, or how the 9 points were allocated for this problem. Part A was worth 3 points. 1 point for using the initial condition, f of minus 2, 1 point for finding the value of f of minus 6, and 1 point for finding the value of f of 5. Part B was worth 2 points for providing the correct answer, and here that means the correct intervals, and for the correct justification. Now, this doesn't mean that students received only 0 or 2 points in this part. There were certainly some possible 1-point responses. Part C was worth 2 points. 1 point for considering the value x equal 2, for conveying that x equal 2 is a value where the absolute minimum value could occur, and 1 point for the correct answer with appropriate justification. There's a lot of work involved for that second point. Part D was also worth 2 points. 1 point for finding the value of f double prime of minus 5, and 1 point for stating that f double prime of 3 does not exist and providing an appropriate explanation. Here are some general comments about the student performance on this problem. First, most students were able to enter the problem, and that means they were able to begin a solution. They presented some correct conceptual calculus steps. There were lots of minus signs in this problem, and this forced students to be very careful in notation and computation. There was a minus 2 and a minus 6, and when computing values of the function f, students had to carefully add or subtract the area of certain regions. In part B, some students were simply unable to properly communicate a justification. And there are always questions about whether the intervals should be open or closed. In part C, some students provided a local argument rather than a global argument in an attempt to justify the absolute minimum value. In addition, some students didn't recognize the need to consider the endpoints when searching for an absolute extreme value of a continuous function over a closed interval. In part D, the analytic explanation to show f double prime of 3 does not exist was challenging. Many students resorted to a geometric description instead, and some of these explanations were acceptable, but others were just too vague. Now, let's consider each part of this problem and a more detailed look at how the points were awarded. In part A, the first point was for using the initial condition, f of minus 2 is equal to 7. The student earned this point if the initial condition appeared in either or both of the evaluations. Here's the general philosophy for awarding this first point. the student must use f of 2 equals 7 on the way to calculating f of minus 6 or f of 5. And here are a couple of examples. In this first case, the student has used the initial condition, but they've added 4 instead of subtracted 4. But they still get the first point. They've used the initial condition. In the second example, the student would actually earn the first 2 points, because not only have they used the initial condition, but they have the correct numerical answer. It's not simplified, but it doesn't have to be. And in the third case, the student has used the initial condition on the way to finding or calculating f of minus 6. The initial condition may also appear in the context of an indefinite integral and an attempt by the student to solve for the constant of integration. If the student uses the point minus 2, 7 in some kind of linear approximation or an appeal to slope, they don't earn the first point. And it's possible for the student to earn the first point by using the initial condition implicitly. If this were the only expression on the page for part A, the student has used the initial condition to actually find the value of f of minus 6 to come up with this value 3. So if this were the only expression on the page, the student would earn the first point. The second point in part A is for finding the value of f of minus 6. And here are some specific examples and how each would be scored. In the first case, the student has used the initial condition and they have provided the correct numerical answer. Again, remember that this does not have to be simplified. In the second example, a property of definite integrals is used. The bounds are switched, and there's a negative sign in front of the definite integral. The student still arrives at the correct numerical answer, and this response would also earn the first 2 points. The third example is a minimal response, and I don't mean to imply that this is an actual student response, but it's sort of like our line in the sand. I can minimally see the use of the initial condition and the correct numerical answer. The student would earn the first 2 points. The last point in part A was for finding the value of f of 5, and here are 2 specific examples. In the first case, the student has used the initial condition and provided the correct numerical answer. They would earn the first point and the third point in part A. In the second example, the student has used the initial condition also and provided the correct numerical answer. Note that the last step isn't necessary to earn the third point. The student could leave this as 7 minus 2 pi plus 3 because, well, that's a correct numerical answer. Here are just a few more general comments concerning the f of minus 6 and f of 5 points in part A. If the student presented unlabeled answers, we'll read those but in the correct order. That means the first numerical answer is understood to be f of minus 6 and the second f of 5. Correct numerical answers for f of minus 6 and f of 5 without any supporting work, that is bald answers, would receive 2 points, 0, 1, 1. The student would not receive the initial condition point. Unfortunately, this problem led to some linkage errors, and that is what I call train of thought errors, or unequal expressions that are connected with equal signs. Here's a common linkage error in this problem. Suppose these 2 expressions appear on the page. In the first expression, the student would earn a point for using the initial condition, but they would not earn the second point for the value of f of minus 6. They've committed a linkage error. However, they can only be penalized for a linkage error once in part A. Therefore, they would earn the f of 5 point. So this student would earn 2 of the 3 points in part A. It would be scored as a 1, 0, 1. Part B was worth 2 points for a correct answer, in this case that means 2 correct intervals, with an appropriate justification. And here's how this scoring standard was interpreted. First, inclusion or exclusion of the endpoints doesn't matter for scoring. Now, some of us think the endpoints do matter when we consider the strict definition of increasing or decreasing, but in this problem, including or excluding the endpoints in the intervals doesn't matter. In the student's written response, if they use the phrase "the graph," we'll assume that that refers to the graph of f prime of x. And if they use the phrase above the x-axis, we'll read that as positive. If the student writes the correct intervals and their justification is that f prime of x is greater than 0, they would be awarded 2 points. If the student provides their intervals using these two inequalities, says that f prime of x is greater than 0 on these two intervals, they would earn both points. If the student provides complete correct intervals without any justification, or a fuzzy but not false justification attempt, they receive or earn 1 out of the 2 points. If the student provides only one correct interval, but the correct justification that f prime of x is greater than 0, they would earn 1 out of the 2 points. If the student provides one correct interval and an additional correct subinterval with an appropriate justification f prime of x is greater than 0, they would also earn 1 out of the 2 points. If we see an interval that lies outside our domain, but it is correct and justified on the interval -6 to 5, then the student would earn 1 out of the 2 points. In reading for the justification, these phrases are considered ambiguous: the function, the derivative, and the slope. And finally, if the student presented any interval in which there were values where f prime of x is less than 0, they would not earn any points in Part B. Part C was worth 2 points, and the first point was a conceptual point for considering x equal 2. It was earned bluntly for considering x equal 2 as a potential location for the absolute minimum value. If x equal 2 or f of 2 appeared in Part C, the student would earn this point. And if ordered pairs were used or presented, we would read only the x values for this consideration point. The second point in Part C was for the answer with an appropriate justification. The student must have and identify the minimum value for f of 2, which is 7 minus 2 pi. Now, even though this was not a calculator active question, some students do the arithmetic with pi, and they could report this approximation. Once again, if a student was working this problem in terms of ordered pairs, we'll read only for the value of f of x. A minimal way to earn both points in this part is to correctly evaluate f of -6, f of 2, and f of 5, and identify 7 minus 2 pi as the minimum value. The student may show evaluations for only f of -6 and f of 2, but they have to include a good reason for excluding f of 5 as a candidate for the absolute minimum. The student can import incorrect values from Part A for f of -6 and f of 5, but only if they're greater than 7 minus 2 pi, because otherwise they've changed the complexity of the problem. And it is possible to justify a correct answer here using a comparison of areas, but the student would have to be very specific and of course correct. The first point in Part D was for finding the value of f double prime of -5. The most common student responses were -1/2, -2/4, or -0.5. In this problem, the answers could be given without a difference quotient. And of course, these numerical answers do not need to be simplified. The second point in Part D was much more interesting. The student had to show that f double prime of 3 does not exist, and they had to provide an appropriate explanation. I just want to remind you that the scoring guidelines show the correct analytical method to answer this question. We need to consider two one-sided limits and show that those values are unequal. Therefore, the overall limit does not exist, and therefore f double prime of 3 does not exist. Here's a minimal response to earn this point. If the student said that f double prime of 3 does not exist, because those two one-sided limits are unequal without any calculations, they would earn this f double prime of 3 point. In the third example, the student is looking at one-sided limits, but they're using f double prime rather than f prime in these expressions, so they would not earn this point. In the fourth example, another common error was to look at one-sided limits, but use the function f in the numerators here rather than f prime. This student would not earn the point. And in the last example, the student is also considering one-sided limits, but they're using f prime rather than f double prime. They would not earn this point. Even though it's not written in the scoring guidelines, readers did award this point for some written as opposed to analytical explanations. Here are some examples of explanations that earn the second point. Students could say that f double prime of 3 doesn't exist because f prime has a corner or a sharp turn or a sharp point or a kink or a cusp. They could even say there was an apex of 2 segments there, or that there was no distinct tangent line. Now, there is some line in the sand. Here are some explanations that did not earn this second point. If the student said that f double prime of 3 does not exist because the graph of f prime has a vertex there, or that it looks like the absolute value function, or that it has a peak or a bounce or a node, or there's an abrupt change in the slope there, or that it comes to a point or is not differentiable or not smooth, or doesn't have a slope there. All of those explanations would not earn this second point. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. And there's also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There's material there involving technology, calculus, classroom activities, and lots of calculator tips and tricks for test success.